Good morning, everybody. This is Tony Battaglia with Freewave, and welcome to our first of many Freewave web video sessions. Now, the idea here, we're going to be creating a series of live videos on a variety of topics. These aren't necessarily intended to be product overviews or just hour-long PowerPoint presentations. These are going to be more informal sessions addressing common topics that we're seeing in the industry, and we want to really contribute some thoughts and idea to the industry, engage with the audience, and this could be anywhere from what we're going to see today from Nate Jones on adding logic to edge devices with open source tools to topics as simple as common deployment issues or best practices, or really anything. So with that said, again, this will be first of many. And as we develop these topics, we're always going to be open ears to any ideas or topics anyone would like us to cover on a later session, or even open to anybody collaborating with us on one of these. We're certainly flexible on the format and flow, so feel free to reach out. With that, just for quick housekeeping before I pass it over to Nate, this video session will be recorded and we will be posting it. We definitely want people to ask questions or engage or contribute thoughts. So if you do have any questions or thoughts, use the chat or questions box below on the go-to interface there, and we'll get those addressed as Nate wraps up here. So with that said, I'll kick it over to Nate Jones, who will kick off our first session.
Thanks, Tony. I appreciate that. So today we're going to discuss decision-making at the edge, and this is going to be a very light look at decision-making at the edge. As Tony mentioned, my name is Nate Jones. I'm a technical account manager here at Freewave, mostly covering the oil and gas markets based out of Houston, Texas area. Today's presentation, I'm going to cover more just generalized decision-making at the edge, not really oil and gas focused. Background has been production automation optimization on oil and gas wells, artificial lift systems predominantly for the last 10 to 12 years. And as far as my edge knowledge and experience, it's really kicked off since joining Freewave, and what you're going to see today using Node-RED has really kicked off in the last month or so. So the goal for today is basically to demonstrate. We hear edge devices, we hear IIoT, Industry 4.0, and SCADA 2.0. The goal is to kind of demonstrate some things you could do with these edge devices using open source type software. Instead of just using them to communicate data, that you could actually put a little bit of brains into them as well. So today's demonstration will be utilizing, or what I'm going to be using for this is two pieces of hardware. The edge device itself, or the device that would be at the far end point of the system, is our new Zoom Edge 900 megahertz Ethernet radio with expandable I/O on board. Modules that you can see there at the top. So it has all the features of our Zoom Link Ethernet radio equipment with the expansion capabilities of our iOS EX modules. And then for the master or the gateway radio, which will be acting as a broker in this instance, is just one of our Zoom Link 900 megahertz Ethernet radios. They are connected wirelessly in my home office workshop here, so they're not too far apart, but this will all be done using the actual RF network. So what does this do, or what could this enable? Logic at the edge is typically done by controllers, PLCs, things of that nature that have a large amount of pre-programmed and pre-designated capabilities. PLCs obviously can be customized. They still do a lot of processing and a lot of capabilities that sometimes aren't needed for smaller applications. Taking advantage of some of the recent edge capabilities, such as MQTT, the publish, the backfill capabilities MQTT presents, can increase data resolution rather than what we're using now with a pull respond typed automation or communications infrastructure. And then using open source platforms like Node-RED, OpenPLC, and there's a few others out there, or just if you have some JavaScript or Python type knowledge, writing your own little code to do something simple based on your application can avoid a lot of the costly, typically sometimes, overly large licensed software products that do a lot of things when you really only need them to do one or two things. And then it can give you a little bit of capability and flexibility that you can tell it to act the way that you want it to act. You can program it to do something the way that you want it to do versus, canned actions or canned, logic that may be in some specialized software and devices. Similar to a PLC, however, with a PLC or an RTU or any other controller, if you're trying to get that data back to your office or to some remote system, or if you have several endpoints that you want to have a centralized control capability on, you're also going to have some communications hardware in with them as well. So now you have two pieces of hardware doing something along these lines like we're going to see today to consolidate that hardware to where the logic and the actual some of the controls and safeties can be on the actual radio itself rather than a separate box. So just a quick overview so everybody can see what we're doing or what I'm working with here. So our broker master is a ZoomLink 900 megahertz radio running our IQ Linux environment and development environment. And on top of that, I'll be running Node-RED, which is open source software that comes pre-installed, or the package is pre-installed with the IQ software, and you can activate it or install it directly from the command line. The remote unit will be a Zoom Edge 900 megahertz IO, wireless IO product, running the same IQ development software and Node-RED as well. And then also on the gateway, I set up a second remote, if you will, just to generate a little bit more data points to look at. That is basically a random number generator to generate some values for me. And then also on the gateway, I'm running the open source Mosquito broker, which is also pre-available with the IQ license you can install from the command line. On the IO itself, I'm going to be simulating a digital input just using a simple switch, and then I've got an analog input using a 5-volt power supply that I will be turning on and off. I was going to do it with the potentiometer, but my potentiometer decided to break. So we're going to go from 0 to 5 and 5 to 0. I've also got a digital output, or 2 digital outputs that we're using strictly for monitoring because we're not doing video. They're not triggering anything per se, like a light or anything, but we'll be looking at the actual registers for them so that we can see the current state. And then the basic logic, we'll have the broker on the gateway. I'll show you the Modbus port, Modbus IDs, that's all just there. TX16 will be my random number generator, so that will be simulating a site or a device we're going to call TX16. And then ZE81 or Zoom Edge 81 will be our actual Zoom Edge IO remote device. That's important as far as when we get into MQTT and how we're getting the data and viewing the correct data when we talk about tagging. And then on the Zoom Edge, we'll be reading the values from the IO. We'll be publishing those values to a broker. We're going to do some very simple logic with them, just if this, then that type logic right there. We're going to scale those values because not all the time will your Modbus value be scaled. And then just show the main part of this presentation will actually be the GUI or the user interface. I don't want to dive too far off into the Node-RED side of it, the flows, because it's not meant to really be a Node-RED presentation. So with that said, we'll go ahead and kick over to the actual Node-RED, and I'll kind of walk you guys through what we're doing and some basic functionality that can be done on the edge. So what you can see here is basically in Node-RED, if you're familiar with Node-RED, these are called dashboards. If you're not familiar with Node-RED, it's basically a built-in user interface that you can download the package for free and install within Node-RED that gives you what are called dashboard or graphical nodes. And so you can use those to create different visual effects and visual capabilities to actually look at your data. So up at the top, these are actually two different internet windows because each device has its own IP address. So at the top, the red will be our remote unit. So that's our Zoom Edge. So this is our actual live IO data here. And then at the bottom, this is what we're seeing at our gateway or our master station. So just to kind of walk through it real quick, and then we'll go into some actual functionality. What we're looking at here is our real-time status, or what I've called the real-time status window. All the labeling, the colors, everything that you see is obviously customizable. So my analog gauge, I've got my live input will be the top, the voltage. I've gone ahead and converted it to a level between 0 and 25 feet and a pressure between 0 and 30 psig, just to give us some ideas on what you can do with scaling. And then I'm doing a simple trend that will trend the data just to kind of show that you can actually get live trends. So if you're looking at multiple different things, you can bring them in by their tag. So if I had 10 different end devices and I was at the master station, I could actually bring in all 10 onto one graph and watch that data locally or at the master. Then my DI status, digital inputs just on or off. So right now, currently it's off. We're not polling anything at the moment. The safety switch, it'll tell me 1 or 0. You can customize this to actually have a text readout. I wanted to keep this very simple. And then the digital output status, so these are the Modbus registers that we're currently reading. So the local SD1, or this is the local shutdown. So this will be comprised of basically if this device, based on an alarm, shuts something down or triggers this digital output. And then I have one that we're going to call the remote shutdown. So that will basically trigger using a command sent from the master or the broker. If we look at the top, basic Modbus to MQTT, so this is where we're going to start. The very simplest thing, not really logic, but just more data collection and publishing. We've done this for a few customers. So this is in its simplest form, some capability of the edge. So what we're going to be able to do here is very simply pull some Modbus registers or and publish them to an MQTT topic that we'll specify. The input setup is the actual 4 IO that I have on this Zoom Edge device. So these will be obviously very specific to this Zoom Edge, which I'll go over in just a second. And then alarm setups, I set up an alarm based on the analog value so that we can trigger that. And I set up an alarm based on the digital input status so we can trigger that. We'll go over that a little bit more in just a moment. So on the master station or the gateway, just so that we can understand what we're going to see in sequence. Basically, our basic MQTT subscribe. So this will be in relationship to this. So once I put some registers or such in here, then you will see those values, or we should see those values populate here at the gateway. I'm also going to be using an app, a free app through Google Chrome called MQTT Lens, which allows me to subscribe and publish messages to a broker and subscribe to messages from the broker to just publish some customized messages showing that you can get data from multiple sources on the same gateway or broker. The input setup will be tied more towards this field current status. So if I'm at my master station, as you can see here, so our ZE81 will be my Zoom Edge device that I'm going to set up top. And then this TX16 is my random number generator, or basically used to simulate a secondary well site. So as you can see, its values are jumping around. They're still scaled correctly. You can see that its inputs are turning on and off. You won't see its remote shutdown trigger randomly because that is controlled by the master that we're going to set up here in a minute. Its valve is open. So that's pretty much simulating its local digital output. So when the gate latches, the valve should open. When the gate unlatches, the valve should, when the gate latches, the valve should close. And that's kind of how that's set up. The field-wide alarming, as I've named it. So basically this is just to show you, this could be labeled Zoom Edge 81 or Texas 16 analog. We're going to set up an analog alarm or an alarm on the gateway. It's basically going to look at any of these values coming in, and if it goes over what we set up as an alarm, then it's going to possibly take an action across the entire field or any device that it can talk to. We're going to do the same thing with the digital, and we'll be able to see that status change not only on our Zoom Edge, but also on our field current status. So the remote shutdown is anything that is being done by the gateway or broker or master station. And then current field status, like I said, my background is predominantly automation and field production automation. So I know when I go up to something, I like to be able to see different things throughout the field. So any alarms that come in basically is subscribed to this current field status, will bring those in, or you could bring those in. So the ZE81 analog alarm, right now it's okay, the digital's okay, so we have no alarms present. If I had 10 devices, I could have them all listed here. I could also set it up to where it just shows me any alarms that are present, regardless of if I've preset up specific remote devices or endpoint devices or not. Basically anything that comes in, if I was to leave what we call a wild card here, the ZE81, and do the rest of it, or I could wild card the end, anything that is published to the Zoom field as an analog would start listing here. Same thing with the digital. So basically, if I had 20 remote sites out there, if I published their alarms using the same scheme, I could just leave the well name itself out, and any of the wells that trigger, I could have bring in here to show me the status only on active alarms. So with that, basically I'd like to start just very simply with the basic Modbus MQTT. So my unit ID, you can specify this here because you can actually set it up in Node-RED to allow you to specify these for different Modbus polling registers or such. You can do as many of these as you want. I just did 4 to keep it simple. If I refresh, sometimes my screen actually puts my values back in. This time it's not going to do it. So this is from our Zoom Edge device. So basically it's all based on the input I have set up. I know that it's Modbus unit ID 100, Modbus address is 40, it's a function code of 4, and there's 2 registers to this. I'm going to publish it as universal 1 because that's the topic. Basically at this point, and we're assuming that topics are already known at the master station or that there's already a topic scheme. So if I hit submit there, and then if I go down to register 2, you can see that universal 1 is starting to come across. We're going to do the same thing. We're going to look at our digital input, which is address 7. Modbus, it's a foil. And then we're going to do that as universal 2. And just hit submit. And now you can see that at my gateway location, now I've got both of those topics coming in. And then what I'm also going to do is take what's called our MQTT lens. I'm connected to my broker. My topic is going to be what you see right there, Chrome. Subscribe, I want to publish. It's going to be Chrome/1, and my message is going to be web test. I will publish that, and as you see, the web test appears right here. So I can do the same thing for Chrome-2, which I'll do off screen, and then just publish that message as well. So it's sampling, I'm publishing, set up to publish. Basically, it's publishing 1 second. So this is 1 second data here. Just looking at this, if I trip my digital input on my zoom edge, now you can see universal 2 changed to a 1. I could have that say something, valve closed or whatnot, but since this is a very basic just Modbus MQTT, it's just set up to be a raw value of what I'm getting. If I also go ahead and trigger my analog input on the same system, because I've set it up, then you should see that now I've got my 5 volts because I've turned that switch on. So as soon as it changed, it's published. You can also add the capability to do report by exception on these. You can add the capability to do different poll rates. For the purpose of this demo, to keep it simple, it's just 1 second poll rate and publish, and report by exception, not on this type. So we're going to unplug that again. So we go back down to 0, 0 here, web test is there. To go a little bit further, if we wanted to add a few more details, or if we have a specific device in mind, like the zoom edge, then I set up these 4. So it's my analog input on my zoom edge, my digital input on my zoom edge, one of my digital outputs, and my other digital output. So Modbus 47, 3, and 2 are my registers. Just real quick, so that I don't get too far out, to show, because I like to know a little bit of where some of this is coming from. So to show this, if I log into my actual zoom edge itself, then just for example, to keep it quick, channel 5, on my edge, it's set up for pressure. It's 5 scaled input. It goes 0 to 5 or 0 to 5 volts. And then I'm looking for Modbus address 40, function code 4, number of registers. So that's all I'm doing is polling that value. I can set these up for different things. There's 12 different channels. As far as my digital input goes, if you look on safety switch 2, it's address 7, function code 2, register is 1. So that's what I'm looking at as my state. And so that's what we're polling here. So if I hit submit, I would type all that in, but I've already done it. So each one of these is tagged with my endpoint name or my well name or my location name. Zoom Edge 81 is what I'm calling this, and then what type of input or what topic it is specifically. So I've hit publish there. So now if I go to my real-time status over here on just on my local device, ignoring the gateway, you can see that my plot is starting to change. My analog is still unplugged, so I don't have any values there. My digital input status, as you can see here, is off. If I turn my digital input on, now we're starting to we see it come on. If I turn it off, we see it go off. I have not tripped my digital output because I haven't set up any alarming yet. And I have not been remotely shut down because I haven't set up any alarming or information on my gateway yet. If I go ahead and plug in or turn on my analog input, then you'll see that it automatically starts to go up. It would be much more visually nice with a potentiometer, but it fell to pieces. So my 5 volts, since I have this set up for 0 to 25 feet, right at 12.5 feet, I have my range on my voltage for 0 to 10, so it's halfway. So this is about a little over halfway, and then 0 to 30. I'm at 5.009, so that puts me just over 15 halfway. So you can see that. You can see that I'm plotting it out here. So visually, it's very nice. Still working at the edge, so communications to my master are not important. Any sort of true outside communications, not necessary at this point to give me some controls. I'm going to basically set up 2 simple alarms. So for my analog alarm, I'm going to give it a high limit right now of 6, a low limit of 2. Non-alarm message is going to say okay. We're going to keep it creative. For my low alarm is going to say low alarm. My high alarm is going to say high alarm. My alarm topic is going to be Zoom Edge 81, sensor 1, alarm. If I keep the same thing over here, I can do my trigger as a 1 because that's on. off as a 0. You can reverse those. So if it's normally closed, you can have your trigger as a 0, your clear or no alarm as a 1. Okay, again, alarm message will just say safety switch tripped. And then alarm topic, we're going to do the same thing again. Zoom edge 81 / we're going to call this safety switch 1 and then alarm. And by doing it that way, keeping the same format, if you're not too familiar with MQTT, the way it publishes and you can subscribe to topics, I can keep Zoom edge 81 in here, put what's called the wildcard in here, and then put alarm at the end. Anything that comes in with Zoom edge 81, anything in the middle, and alarm will show up in one spot. So I could have that all go to one spot. Now for my actions, if I want it to trigger the digital output, I can tell it to trigger the digital output. And then RBE is report by exception. So do I actually want this alarm to be sent based on my publishing cycle, or do I only want this alarm to be sent or to transmit and take an action based on a change? So to keep it easy, we're just going to trigger the DO. We're not going to worry about the report by exception. We're going to hit submit here. We're going to hit submit here. So both of my alarms are set up. So if I go back to my real-time status, that's not tripped. So as you can see here, I do not have a local alarm or a shutdown trigger. If I trip my digital input, which is the easy one, you see that triggers. Nothing happened on my shutdown, and that's okay because it wasn't supposed to happen yet. If I go in here and pull my analog value, then you should see my analog go down, and you see my shutdown triggered. And that could be something I did on the digital side. If I put that back in there, then you can see that my local shutdown has cleared and my analog value is back up. I can do the same thing right now by simply changing this value to a 4. So anything over 4 is going to cause a problem. I hit submit and go to my real-time status. So you can see that my shutdown has triggered. If I change this to a 0 so that I don't have a lower limit, then I can unplug my analog, it drops to 0, and my shutdown goes away. So that in its sense is your very basic logic. So all we've done at the edge using the open source is basically tell it you're already getting the value. In this case, it has the IO on board. So we're wired into it. Whatever our end devices are wired directly into the radio or into this device. And instead of just communicating that data so that something else can make a decision, or instead of relying on another control panel to make a decision, I can set it up to make some simple decisions on its own. Okay. So that's at the edge. So now what we can look at on our real-time status is I've got nothing running. At the edge, we're going to go ahead and turn this alarm off. We don't need a local shutdown as well, so we're just going to tell it a 6 for right now. So we don't see any of that. I'm going to go ahead and plug my analog back in so that we can go over to the gateway and look at how the data transmits over to the gateway and what we can do with it there. So we've got that back, no local shutdown, no remote shutdown. So now if I go to my gateway, you can see that my ZE81, which is my remote, I've got 5 volts. My safety switch is not tripped. That safety switch 1 is not tripped. If I go ahead and close it again, you can see it is tripped. So you see the top one change at the same time the bottom one does. So my publishing is working. If I go to my current field alarm status, both of these are okay. If I wanted to set that up as an alarm, I could change this to a 4 per se, and hit submit. Go to my real-time status. And I think the webinar is eating into a little bit of the bandwidth. ZE81. So as you can see, here's the topic that it's subscribed to. So that shows you right there that it's important. If I go to my alarm setup, I could put it in here, put the same topic into there, see if that works, and hit submit. But topics are obviously important. Apparently that one I have broken somewhere along the way. So if I look at my field-wide data, I've still got that coming in. We're going to go ahead and clear that local alarm, which you can see the local shutdown over here on the right-hand side. So if I hit submit, clear the local alarm, that local shutdown goes away. We're no longer alarming at the edge itself. So I could do what I call field-wide alarming. This is basically alarming based on an input. So we're going to do the same thing here. We're going to tell it alarm high limit of 6, low limit of 2. Non-alarm message is okay. Low alarm message is going to be low alarm, high alarm. And then for this one, we're just going to call it the Zoom field because that's what it is. ZE81 is the location that I'm going to be looking at for this particular field-wide alarm to get an input from. And then we're just going to call it sensor 1. We're going to submit that, so it should be okay. And then if we go to, we're going to go back to the status there because that's what's really going to matter. And then alarm trigger, we're going to say 1 and a 0. Okay, and then alarm message will be, local safety switch trip. And that will work for that because we're looking at the alarms coming from the ZE81. Same thing here. And we're just going to call this SS1 alarm just to keep it simple. And I submit that. And now that I think about it, that is what our current field status is going to be. So these two are basically, once that alarm is set up, it will look at anything that goes into alarm and tell me. So field current status, everything is good. I don't show any alarms. If I trip the digital input from the field side, so this is on my edge, so you should see at the top screen the DI status. You should see the DI status go on. And then on the bottom screen in the middle, you should see the ZE81 safety switch trigger. So, and then also, because I set an alarm up anytime that it triggers or I see a shutdown from that, I want to shut down the whole field. On the digital outputs, you should see the ZE81 remote shutdown trip, as well as the TX16 remote shutdown trip. And good. And as you can see, so I triggered the digital input on the edge. It saw that I triggered it, and it caused the master unit to basically shut down or trigger an action on all the devices I specified that are connected to it. As you can see up here on my edge device, since I'm looking at the remote shutdown status, because if I'm out there and it's not working, I want to know why is this thing not working. I can see that it has been shut down remotely. If I disengage my digital input, so everything is okay, then I should see that go off. My remote shutdown disengages because the gateway is no longer telling it to stop. I see both my statuses clear on both my end devices. You can set it up to not clear. You can set it up, to do multiple different things. And then if I go to my field-wide alarm status here and do the same thing again, so now you can see that my ZE81 local safety switch trip. So based on the alarming that I set up, that's the message I get. So if I just had a status screen of all my current alarms, I could just walk up, see this, and I would specify, I know that it's that location. It's okay. Oh, that location, my local safety has tripped. So that's the digital input at the local location. So again, the goal was very basic logic. It was not, there are, I am sure, multiple ways to do this. My node red abilities, for those that it looks like a lot, are about a month old. So it took some figuring out, and I kind of tried to do it in the simplest of ways. But that's pretty much the main part of the demo, is just kind of showing that you can bring the data in and not just bring it in and communicate it, but you could actually do some things with the data at the actual end, as well as, you know, the midpoint there, which is also part of the edge. But that's all I've got.
All right, Nate. Thank you so much for going through that. I didn't see any questions or comments come through, but we'll open it up for those. If anybody has anything they want to ask, contribute, whatever it may be, if you could put it in the questions or chat box. And if not, we can wrap up this session and pick up at the next one. All right. Well, thank you everybody for joining. We'll have another one of these sessions coming up here pretty soon. Like I mentioned earlier, we're certainly open for any ideas you guys may have, thoughts, topics, questions you'd like us to address, and we'll create a video accordingly. So feel free to reach out. Thanks again, and I'm sure we'll be chatting with all you guys soon.